This video, we're going to talk about the definition of the Laplace transform, which is definition 7.1.1 in the textbook. So let's go ahead and start with number 11 here. And I'll tell you definition 7.1.1 says that the Laplace transform of a function f of t is equal to the integral from 0 to infinity of e to the negative st times f of t dt. I know it's kind of one of those things right now where you want to say, why do I need to know that? It's just like how we learned the limit definition of the derivative or the limit definition of the antiderivative. And we had to learn the definition first before we can go and start looking at tables and things like that, which will be the next video. We'll look at some basic things that we can do there with known functions and how they transform here. So let's go ahead and look at number 11. And our f of t is going to be equal to e to the t plus 7. So our Laplace transform of e to the t plus 7 is going to be equal to 0 to infinity of e to the negative st times e to the t plus 7 dt. I want you to ask your teacher how they want you to write this, whether they still want you to write the limit as b goes to infinity and replace the infinity with a b since it's a improper integral there with an upper limit at infinity, or whether they're okay with you leaving that notation and knowing what it is. I'm going to pull the stuff out that doesn't have t, the e to the 7th that was multiplied there, because it's a constant multiplier. So I'm going to have e to the 7th on the outside, 0 to infinity, e to the t minus st dt. I'm going to factor that common factor of t out. I'm actually going to factor out a negative t because I want something to be obvious here. So s minus 1 here is that part that's got the s in it. It needs to be positive. So we'll be dealing with that there in just a minute. T is also going from 0 to infinity. It's positive. So this negative sign is going to force this exponent to be negative when we multiply a positive number times a positive number. We're going to get a negative number up here. That's going to be important in a little bit. So I just want you to know that both of these parts here are going to be positive numbers. Let's go ahead and use our exponential rule with u substitution. Remember that s minus 1 is a constant because we're only differentiating with respect to t. So this is the idea of like partial derivatives type idea, but I want to take the derivative of this with respect to t, and I get negative s minus 1. So that gives me a negative e to the 7, e to the negative t, s minus 1 over s minus 1 as my antiderivative. I need to evaluate that from 0 to infinity. Again, ask your teacher if they're okay if you writing the upper limit of infinity that way. I am, maybe your teacher's not, wants you to write the limit as b goes to infinity and put a b there and take the limit like you did in calculus 2. So upper limit of infinity, e to the negative infinity up here is going to go towards 0. So this is going to be 0. The minus the negative is going to be positive, e to the 7th. Put in 0 for t, we get e to the 0 over s minus 1. So that gives us a total answer of e to the 7th over s minus 1. Let's move along here to number 13. And we're going to have f of t is equal to t e to the 4t. So we have 0 to infinity, e to the negative st times t e to the 4t dt. So 0 to infinity, t e to the 4t minus st dt, and 0 to infinity, t e, again, I'm going to pull out a negative t here, s minus 4 dt. So I'm going to do integration by parts. U is t, dv is e to the negative t, s minus 4 dt, du is dt, v is going to be negative e to the negative t times s minus 4 over s minus 4. So we get uv, it's negative t, e to the negative t s minus 4 over s minus 4. That goes from 0 to infinity, minus the integral of v du, so minus a negative, e to the negative t. Let's pull out this constant part, s minus 4 dt, like so. So that goes to 0, and that goes to 0, so this is a big 0, plus 1 over s minus 4, and then this is e to the negative t, s minus 4, negative, and s minus 4 down here, 0 to infinity. And so 1 over s minus 4 times infinity is going to go to 0. And then this is going to be 1 over s minus 4 gives us 1 over s minus 4 quantity squared. Number 15. F of t is going to be equal to e to the negative t sine of t. So the Laplace transform here is going to be integral from 0 to infinity, e to the negative st, e to the negative t, sine of t dt. And I'm going to have 0 to infinity, sine of t, e to the negative st minus t dt, which is 0 to infinity, sine of t, e to the negative t, s plus 1 dt. I'm going to call this I because I can already see that with the sign in there and the exponential function that this is going to loop around on itself. So I'm going to call that I on my left-hand side and just leave that there. My u is going to be the trig function sine of t. My du is going to be cosine of t dt. My dv is going to be e to the negative t times s plus 1 dt. So my v is going to be a negative e to the negative t times s plus 1 over s plus 1. So I is going to be equal to uv, so that's negative sine of t e to the negative t s plus 1 over s plus 1 from 0 to infinity minus the integral of v. So this is 1 over s plus 1, 0 to infinity, cosine t e to the negative t times s plus 1 dt, like that. And we'll simplify this a little bit. I equals infinity. This part's going to be 0. That part's kind of a constant. So 0 plus 0, that's 0, leaving me with 1 over s plus 1. Integral 0 to infinity of cosine t e to the negative t times s plus 1 dt. So now my new u is cosine of t. My du is a negative sine t. My dv is equal to e to the negative t s plus 1 dt. And my v is equal to a negative e to the negative t s plus 1 over s plus 1. So let's scroll this up now. I is equal to 1 over s plus 1 times, then uv, so negative e to the negative t times s plus 1 over s plus 1, evaluated from 0 to infinity, minus integral of v du, so that's 3 minuses, there's still a minus in here, integral 0 to, well, let's take the constant out here, 1 over s plus 1, 0 to infinity of sine t e to the negative t s plus 1 dt. So let's go ahead and simplify some things here. This is, when I go to infinity, this is 0. S plus 1 times 0 plus, and then that's going to be 1 over s plus 1. And I get minus 1 over s plus 1 squared when I distribute that s plus 1 from the outside in. And then this is my original I right there. So I have I is equal to 1 over s plus 1 squared minus 1 over s plus 1 squared I. So 1 plus 1 over s plus 1 squared I is equal to 1 over s plus 1 squared. And let's multiply through here by let's make a single fraction on the left-hand side. This is s plus 1 squared plus 1 over s plus 1 squared I equals 1 over s plus 1 squared. So when I multiply by the reciprocal, that my answer for my Laplace transform is in the form of 1 over s plus 1 squared plus 1. That is a correct answer, but we're going to simplify that because we're not supposed to be reading it like that off of the table, even though that's what it looks like on the table. So I'll simplify that a little bit more. 1 over s squared plus 2s plus 1 plus another 1 gives me a final answer of 1 over s squared plus 2s plus 2, and that's the way your answer is going to look for this problem in the textbook, even though you're probably going to start off with something like that once we start reading from the tables. So let's go ahead and look now at actually, that'll be it for this video. We'll come back and do another video based off of theorem 7.1.1. So we started off with definition 7.1.1. We'll come back and start with number 19 next time with theorem 7.1.1, which is our table of the Laplace transforms of some basic functions. And we'll come back and do that next time. See you for the next video.